बेटा सिस्टम का ये जोड़, तेरे हाथ में ये सब गोल, तू है भटका हुआ भूगोल, देगी तुझको बख्श ये दुनिया खूब निराशा खूब हताशा, खूब निराशा खूब हताशा, मत सुनेंगी ये धुनेंगी, तू बढ़ता जा बस बढ़ता जा, क्रैक करते जा, जोर लगा तू जोर लगा, कुछ कर जरा कुछ कर दिखा, किस्मत तेरी मेहनत बन के मौका बेटा लाई है, क्रैक करते जा, चैलेंजेस उठाए जिससे ट्रॉफी भी उठाई है, क्रैक करते जा,
Hello everyone, welcome back. Welcome to Unacademy. Now I'll be continuing the discussion on questions on magnetic coupled circuits. So far I discussed two parts in this magnetic coupled circuits. For electrical engineers, it's needless to say, each and every question you need to practice a lot. It's not just a part of a networks, it's also a part of machines. Okay, transformers, induction machine, all these machines, because all these machines are electromagnetic circuits. Okay, so you should be very careful with these coupled circuits. Okay, at simple topics you need to be aware of it, but most of the students are not aware of these topics. Once you're aware, I don't think you'll find any difficulty in understanding these. Okay, the only thing is you should be aware of these facts. So I recommend you to watch it multiple times. That's it. If you by watching it multiple times, that will train your brain much better. You'll be having, your brain will feel like it's a old topic. Okay, if you just watch it once again, after maybe a few months, if you come across this topic, you'll feel like a fresh one once again. Okay, so I recommend to watch these questions, watch these videos multiple times and practice it. Okay, watching is the first thing. Second thing is you need to have a practice of it. So in the first part I discussed a simple inductance calculation. Okay, inductance calculation for a coupled circuit. Okay, how to find out the inductance in different cases, that's what I discussed. And the second one, very important one, KVL equation. Okay, writing KVL equation for any given network. And a KVL equation, when you're writing KVL equation, you should be careful with the inductor voltage. Inductor voltage, you should be very careful with that. Okay, very careful with that. Now in the third part, let's discuss transformation of the parameters, transforming parameters from the secondary to primary, so that you can find out the equivalent impedance or equivalent resistance, like that. Okay, anyways, it will be more clear what I'm going to discuss very shortly. Let's jump into that. So first part, what I would like to say, just give me a sec. The very first part, what I would like to say is, in case of a transformer is a coupled circuit, right? Transformer is a coupled circuit. I think all of you would have seen this transformer for sure. All of you would have used also transformer for sure. Yes, I'm using the word, you might have used it, not you might have used, you must have used it, you have used it. Okay, transformer in some part of your, in some circuit, definitely some circuit you have used transformer. So transformer is a coupled circuit. Okay, means you have this, this something like this. It's connected through magnetic coupling. Okay, it's a coupled circuit. Not only this, your fan, the fan which is turning, that's a coupled circuit. That's a coupled circuit. Anyways, suppose I have a transformer. Let's talk a little more about this transformer. Okay, let's talk a little more about this transformer. Just a little more. This is a voltage, induced EMF or V1, let me call for now. This is V2, this is I1, and here current will leave. This is I2, exclusively for transformer. If you want to take it inside, you can take it inside. Just representation, right? So, a number of turns, N1 is to N2. Okay, the relation what you should be careful with this lesson is V1 by V2 is equal to N1 by N2 is equal to I2 by I1. This is a relation which you should be careful with this. Okay, you should note in this lecture. Now if I just rewrite this, all these are equal, Now what if you want to say V1, what if you want to say, what's the value of, tell me, V1 by V2 into I2 by I1 is equal to, would you mind if I say it as whole square? Because this is also equal to this is also equal to this. If I multiply this will be whole square, right? No objection. I can move forward with this note. I'm just taking it forward. So this term, if I rewrite this part of equation, V1 by I1 whole divided by V2 by I2 is equal to N1 by N2 whole square. Okay. Why I'm doing all this stuff, you will very shortly see why I'm doing all this stuff. Okay. Very shortly you'll notice why I'm doing all this. So what is this V2 by I2? What is this V2 by I2? Suppose if there is something connected here, if there is something connected to this, some load is connected here, V2 by I2 means the load impedance, whatever is secondary impedance, not load impedance, it's secondary impedance. V2 by I2 is a secondary impedance. Alright, careful with this. Now, I have connected some load here. I have connected some load ZL. Here only, this is an ideal transformer. This is a perfect ideal transformer. There is no resistance, nothing. Coefficient of coupling is perfect. Of course, inductance is there, and there is a voltage. Now tell me, here onto the other part, there is no electrical connection between these two. Magnetic coupling is there. There is no electrical connection between these two. There is some load connected here. There is some source connected here. Now tell me, what is the input impedance? Input impedance, what will you say? Will this affect here? Yes, it will affect it. How it is affected, that's what we want to see here. How this will be affected? What is the impedance seen at this? Simply, I can say V1 by I1 is impedance. V1 by I1 is the input impedance. Just basics, Ohm's law. V1 by I1 is input impedance. Now, I can take this one as V1 by I1 as input impedance. Input impedance. Or else, I can say this load seen by the source. Load, this load, if this would have been connected here, what effect? How much will be the effect? So, I can say ZL or Z2, let's call it a Z2. Z2 referred to the primary. Z2 referred to the primary. 2 I am writing 2, second coil. This is the first coil. First coil prime, second coil second. Geo prime, Amazon prime. Okay. Z21. This is Z21. What is V2 by I2? V2 by I2 is directly Z2. Careful guys, interesting thing you're going to get now. So from this I can say Z2 prime is equal to Z2 into Z2 into N1 by N2 whole square. Means if I connect some load here, the source will see that load as how much? This much. For the source, this Z2 will appear as Z2 into N1 by N2 whole square. Okay. Why I am writing in this form? Exclusively I am writing in this form because it is easiest form to remember. I'll tell you what is the ease of it. What is the ease of it? I'll tell you. You will get to use this in machines, induction motors, single phase and three phase. So very important thing if you are an electrical student. Now see here, Z21 at the top we have 1, here numerator 1, bottom we have 2, denominator 2, and 1 by N2 whole square, need to keep it. Okay, don't try it in terms of transformation ratio, number of turns, all this stuff. Directly write this way. This is the easiest way to remember. Okay. Anyways, this is a formula which you should be very careful. Suppose what if I want to transform some parameter onto the secondary side. There is some resistance here. If you want to transform to the secondary side, if that is the case, if that is the case, then suppose Z1, if I want to transform to the secondary side, Z1 referred to the secondary. So Z1 referred to secondary means Z12. Z1 is actually on primary side. I am seeing from the load side. I am seeing from the load side. So Z1 referred to secondary. Now guess what is the formula? Is equal to Z1 into, on top we have 2, N2 by N1 whole square. This kind of thing is true for resistance, reactance and impedance. If it is voltage, you will not have square. If it is current, you will have reverse. Anyways, nothing to worry about all these things. You will see, you'll get to see all these things in case of machines. For now, this is enough. For now, this is good enough. These two are good enough. Okay. Our lectures will be based on at present this practical questions. These questions will be based on these concepts. I think you understand these points. Let's just start a question. That will make things more clear. Okay. One of the previous gate question I'm taking up so that you'll understand the concepts. If an ideal transformer has an inductive load at port 2 is as shown below. Then the equivalent inductance at port 1. That's a question. Circuit is something like this. Simple circuit, very simple circuit. Ideal transformer is given. Ideal means what? Perfect coupling. K is equal to coefficient of coupling is 1. Coefficient of coupling is 1. Okay. This is a transformer, ideal transformer. Now, load side we have something pure inductor is there, inductive load is there. This is the load. It's given in the circuit. L is at the load side. And this is what they'll call it as port 2. Port 2. With reference to this is port 2. They are given like this, port 2. And here this is port 1. Okay. Now options. You can quickly take the options. Option A, n into L. Option B, n square into L. Option C, n by L. Option D, I think you can guess, n squared by L. Okay. I'm going to just bring it down so that you can see clearly. Okay. I think it's clear now. See guys, it's simple. It's simple. Just now I discussed a concept. L is here. Referred to primary side, how much this will be? I want to refer this, let's take it as Z2. Z2 referred to primary, that's what a port 1 is equal to Z2 into, at top we have 1 and 1 by N2 whole square, number of turns. So what is the value of Z2? It's L. L into N1 is small n, n by 1 square, n square. This answer. Answer is n square into L. I took more time to write, but very short time to explain. It's very short, very simple. Okay. Shall we move on? Next question. We'll use these concepts now. We'll use these concepts to, solve the questions. Look at this. Try to answer if you can. Find the value of I1. So 20 by 3 is answer? Wrong. 20 by 3 is not answer. Of course, it is not mentioned anything here means what? It's an ideal transformer. Coefficient of coupling is 1. 1:2 is there. 1:2 is the transformation ratio. Turns ratio 1:2 and 1:2 is 1:2. So there is some resistance here. So this is inductively coupled circuit through ideal transformer. Perfect coupling is there. There is a magnetic coupling between these two. Let's make an electrical conductive equivalent of this. Means transform this to the primary side. Then it will be a simple network question what you are very much aware of. Okay. So try to convert the things into our comfort zone. So that's what I'm trying to do here. I'm keeping this as it is, this 3 ohm as it is. Here we have 20 at an angle 0 degrees. It will be easy if I transform this 4 ohm to the onto the primary side. So I cannot keep same 4 ohms. Okay, the resistance effect will be different. How much is it different? So I'm putting it to the primary side. Then 4 into 1 by 2. This 4 is coming to the primary side, right? 1 by 2. That is n1 by n2 whole square. N1 is 1, n2 is 2. 1 by 2 whole square. Same formula what I used. So 1 by 4 into 4, that is 1 ohm. is 1 ohm. Now 20 by 4. I don't think you'll feel any difficulty to find now this current I1. See how simple is this? 20 by 4 is 5 at an angle 0 ampere. This is a current. This is a current. Okay. So once you convert this into complete conductively coupled circuit from the inductively coupled circuit, then things will be much easier. Okay. Let's go to the next one. If you're done with this, if you have any questions, just go back and watch it once again, then you will understand things. Okay, you might be having some questions based on this, but they're very simple. I given the concepts earlier. Okay, all these are driven based on these concepts. The concepts what I given here, the same thing. Okay, if you have anything, just go back and give it a try. Give it one more watch. Give it one more watch, and then things will be more clear. I think I should move on. Yeah. Now, impedance seen by the source in the circuit in figure given by. Okay. You need to find the impedance seen by this source, this bloody source. How much is the impedance? Alright. How much is the impedance? You have 4 options. Just choose one, not a fluke. You need to answer properly. Impedance seen by the source. ZL is there, transformed to the primary, so that's it. So 4 plus, I can just make it a box. These both things I can make it as 4 minus J2 ohm is 1. The moment you transform this to the primary side, 10 at an angle 30 degrees, 10 at an angle 30 degrees is coming to the primary side, means N1 by N2 whole square. Use the formula what I given, same formula. N1 is 1, N2 is 4. The ratio, it's not N1 and N2 values, that's the ratio. 1 by 4 is the ratio, whole square. Okay. So you would be getting 1 by 4 whole square. I have a calculator. Let me just quickly calculate the values of each and everything. 1 by 16, 10 by 16. You would be getting 0.645. This will be the value which is referred to the primary side, means if I draw a circuit, equivalent circuit quickly, we'll have a box of this 4 minus J2, 4 minus J2. Then you will have another box of 1 by 4 whole square is 10 by 16 is 0.625 at an angle 30 degrees. This will be same. Now if you just convert that into a rectangular form, because everything is given in the rectangular form, I'm just converting into rectangular form. 0.625 at an angle 30 in rectangular form. Yep. 0. This after converting into rectangular form, 0.54 plus J 0.312. Now add these two, 4.54 answer is C. Because real value is matched, its answer. Imaginary value also can match it, you will get different with this. These are only which matches the options. Okay. So things will be very easy if you know the basics. Most of the students, by looking at these kind of circuits, they will stumble, how to approach, because they're not aware of the technique. That's it. Once you're aware of the technique, it's not difficult. Okay. Throughout the engineering process, you are just getting awareness of the techniques, different techniques. Okay. Once you're done with that, it's damn bloody easy, man. Engineering, you will love engineering. You'll fall in love with engineering, not with a girl. Now, let's see how many of you can answer this. Find the power delivered to secondary of the transformer circuit. How much is the power delivered to the secondary of the transformer? Just give it a try. Power delivered to the secondary of the transformer. And the transformer is, it has two parts, two things. This is completely secondary, right? How much is the power consumed in this? That's what they delivered. I repeat, the power consumed in this is delivered to the secondary from the primary. So question is asked, how much is the power consumed in this? Power consumed in these two. That's what the entire secondary, right? So how do you do it? I think we'll transform this to the primary side. Simply transform this entire part to the primary side, and now we have a voltage source and this and this. I know I told you how to transform the resistance to the primary side. Just will multiply with it. But what is this? How do I send this to the primary side? Okay. So to get a specific value, we'll convert this entire one into one equivalent resistance. I repeat, this is I1, this is I1 by 2. I'm converting this into, I'm just finding the equivalent resistance of this whole secondary. I repeat, I'll find the equivalent resistance of this whole secondary. I'll transform that secondary to the primary. Then things will be easier for me. Okay. So let me just take this part only. And now I think it's your cup of tea to find resistance. You know how to find the resistance. You must be knowing how to find resistance by now. These are dependent source we have. This is I1, and we'll apply test source method. Test source method, let me apply, we have 5 kilo ohms, so let me apply 5 kilovolts. What's wrong? AC or DC? Resistance calculation, right? It doesn't matter. So 5 kilo volt. So that this current is 1 ampere. I'll deal with easy numbers. And this current is 0.5. 0.5 is entering, 1 is leaving. So current here must be 0.5 ampere. So resistance between these 2 points is how much? Resistance between these 2 points how much? 5 kilo by 0.5 means you'll be getting 10,000. 10 kilo ohm is the resistance between these 2 points. Now, once you do this simple thing, things will be bloody easy. Okay? How things will be easy? Simply, this entire thing I can replace now with 10 kilo. That 10 kilo will transform to the primary side. The moment I transform the 10 kilo to the primary side, let me just draw the remaining primary circuit. What is already available with me? This is 100 ohm. And this is 50 volt. Okay. Now 10 kilo is transformed to the primary side. 10 kilo is transformed to the primary side. 10 kilo into N1 by N2 whole square, 1 by 10 square. 1 by 10 whole square actually, 1 by 10 square. 100 means you will get 100 ohm. So this resultant you will get as how much? 100 ohm. Let me write here 100 ohm. Now 50 volt is there. Current 200. 50 by 200 is 0.25. So power consumed in this and power consumed in this both are equivalent, right? Power consumption will not change. After transforming, power consumption should not change. That's when the transformation is valid. Power consumption will never change. So 100, 0.25 square into 100, 0.25 square into 100, I square R is the power consumed, 6.25. This is the answer. 6.25 is the power consumed in this 100. That's what equivalent of this. So answer is this. See, once you know the technique, I told you, right, things will be easier. Try to watch multiple times. That's the only tip. That's the only shortcut. That's the only method. That's the only way. Clear with it? Next one. A little tricky. Not a much. Find the value of N1 such that maximum power delivered to the load. Okay? Maximum power delivered to the load. What should be the value of N1 so that maximum power will be delivered to the load? We know for maximum power transfer theorem, it's application. This is the beauty of the transformer. Transformer is for the maximum power transfer. Here we have 2 ohm. Here we have 8 ohm. Do you think maximum power will transfer? No. Means suppose I have a source. I have a source here. Source resistance is 8 ohm. I have a user. User is having a resistance of 2 ohms. I have a user whose that appliance is having a resistance of 2 ohm. Then he is having some specific. We are providing already some specific supply. There is some specific voltage source. Now do you think maximum power will transfer? No, it will not be transferred. For the maximum power to transfer, this must be 8 ohms. These two must be equal. But user is very strict. No, I lost the user. No sir, you change it to 8 ohms. Then he will say, who the hell are you, man, to ask me to change? I'll not change because my load is fixed. According to me, you design your things. But the source is also fixed. You cannot change the source, you cannot change the load. Yet you need to maximum power transfer. There the actual engineering comes. There is a mismatch between these two. I cannot change this, I cannot change this. Yet I need a maximum power transfer. How is it possible? That's the transformer can do it. That's the another application of a transformer, which is called as impedance matching. It will match the impedance. Let's see how it will match the impedance. Now if I place a transformer, though I have 2 ohm resistor, but onto the primary side it will appear as how much? 2 into, onto the primary side it will appear as 2 into N1 by 40 whole square. Now by choosing properly value of N1, I can make this equal to 8 ohm or 10 ohm or any ohm according to your wish. Provided of course they should withstand this much voltage. Voltage levels will be different. They should withstand, but we're talking about only, we cannot satisfy hundreds of conditions at a time by using this transformer. Okay, we can satisfy one condition definitely. Definitely we can satisfy one condition. 2 into, it will easily satisfy, you can easily satisfy one condition. What's wrong in that? 2 into N1 by 40 whole square is equal to 8. Okay, so you just simplify this and find the value of N1. 2 into this is, it's gone to the other side, 4, 40 square by 4, 40 square into 4 rather, 40 square into 4 under root. You will have N1 must be 80. After solving this, you will get N1 is equal to 80. Means if you choose N1 is equal to 80, then maximum power transfer will be transferred with the help of the transformer. That's what the application of impedance matching. Most of the people might be thinking transformer is just useful for only changing the voltage levels. Of course, that's true. But that's not the only one. Another popular one is impedance matching. The third one, isolation, electrical isolation. See, there is a perfect electrical isolation between these two. What's the advantage of having this electrical isolation? That you will definitely see much better when you go to power electronics. Okay, I don't think you'll be able to understand if I say now, so I'm not talking about all this stuff. Right now, we're just talking about the questions. Okay, but that, just take a note. It's for the good electrical isolation. Let's go to the next question. I hope this is clear. Impedance matching application is clear. These questions are, very interesting questions. Okay, very interesting questions. Of course, gate questions too. It's not just because of gate question it's important. They are having some, some point in it, some valid, nice, perfect point in it. Okay. So another question of gate. Let's just take it. I'm drawing the circuit. I'll tell you what is the text in it, what to find. Just take the circuit for now. 100 volt. This 100 volt is RMS value or peak value? RMS value. We have XL is equal to 10 ohm. They're saying ideal transformer. This is an ideal transformer. This is an ideal transformer. We got here 40 kilo ohm and this is 80 kilo ohm. The ratio is 1:100. Okay. Now you got to find current I. Okay. Find this current I. How do you find this current I? Transform these things to the primary side, then it will be a simple AC circuit, conductively coupled AC circuit. Okay, so transform these two into primary side. That's it. How do we get it? Let me just have that untouched one, this is untouched part. Inductance, so J10, this is 100 volt, fine. Now resistance will be resistance, the parameter will not change, the value will change, that's it. The value will change 80 kilo into N1 by N2 square, because it's coming to the primary, N1 by N2 square. I told you the logic earlier, this is the logic I said, right? Here I told you everything, how to proceed with this, right? Z2 referred to the primary, we have 1 at the top, 1 in the numerator, 2 in the denominator. This technique will be very much helpful. You don't have to memorize it. Technique, know the technique. Once you know the technique, your mind will automatically train you. Okay? It's a mind game. So 80 kilo into 1 by 100 square. 1 by 100 square. Okay. So here we have 4 zeros. Here we have only 4 zeros. So you will get 8 ohms. After solving this, you will get 8 ohms. And what about this? 40 kilo into 1 by 100 ohms, so you'll get minus J4. 40 kilo is a reactance, capacitance is minus J, simply minus J4. Okay. Now, it's simple series circuit after all. After all, it's a simple series circuit. Can't you bloody find this current I? I is equal to 100 by total resistance is 8. This is minus J4, this is J10. Both are in series. J10 minus J4 is 6. 8 plus J6. 8 plus J6. Now, square root of 8 square plus 6 square. We want a magnitude. We're interested in only magnitude. It is also only for magnitude. So fill in the blank question in just recent gate exam. 100 by 8 square plus 6 square. 100 by square root of 8 square plus 6 square. 10. Oh, 8 square plus 6 square under root is 10. I missed it. You should know all these points earlier, beforehand. 3 square plus 4 square under root is equal to 5. 8 square plus 6 square under root is equal to 10. They are the most frequent things. And cos 0.8, cos inverse 0.8 is 36.86. Its corresponding sine value is 0.6. These are the most frequent things what you come across. Okay. What are the most frequent things you come across? Square root of 8 square plus 6 square. You can directly write 10. 3 square plus 4 square. This is 5. 0.8. If cos phi, they will give it as 0.8. Phi is equal to 36.86. Okay. And corresponding sine phi, sine 36.86 is 0.6. Okay. And there are a few more aspects like I forgot. Yeah. 50 hertz frequency. 50 hertz frequency. Okay, if it is 50 hertz frequency, 4-pole machine, the speed is 1500. Okay, so these things it should be, because that quite commonly you will encounter these kind of things. So you should not waste your time in doing it. Okay, but of course nothing wrong if you have any doubt, solve it, no problem. If you have any doubt, you can solve it, no problem. But don't commit mistake. That's the only point. Anyways, this is clear. 10 ampere is answer. Answer is 10 ampere. Next question. Take it up. It's not visible completely. Yeah. Now it will be visible. You should be a little smart in solving it. Here we got couple of transformers. It's not just one transformer. Cascade of transformers are there. In power system network, you never know how many transformers will be cascaded one to other. Okay. Here just we got 2 transformers after all. Okay. But in actual power system network, we might come across many. Clear? Now, anyways, focus on this. Focus on this. Try to answer this. First focus on the last one. Transform this to here. Transform this to here. Then these 3 will be in series. Then transform this to here. Then you will get a simple circuit. Okay, that's a simple circuit. What a regular one which you can easily solve. Meanwhile, get a few more questions. I'm looking for one more interesting question. No. I don't have here. Solve it quickly. The idea is very simple. You will transform first this one to here. Okay. So when I take this one to here, then this entire one will be replaced with the resistance. This entire one is gone and is replaced with the resistance. I don't think you understand like this. Let me draw it quickly. That makes more sense because they are the only times you come across these kind of equations, right? I don't want to take chance. Here transformer is there, coupling is there. I don't know, draw the lines, it's okay, leave it for the clarity. We have 4 and this is 2, and now when you transform this to the primary side, here you will get something. These will be as it is. This is 4, this is 2, this is 4. These are as it is, but this value will change. This value will change. 4 will become 4 into 1 by 2, 1 by 2, 1 by 2 whole square. That is 1 ohm. That will be 1 ohm. So I can replace this entire one. 4 has become now onto this side. It has become 1 ohm. Now these three are in series. These three are in series. What is the resultant? If you take these three are in series, the resultant is 7 ohm. Now again this 7 has come to, if this 7 comes to the primary side once again, if this 7 comes to the primary side, do something wrong? Yeah, fine. If I bring this 7 to the primary side, then what will have? You will have a circuit something like this. It's a 4 ohm. And this entire 7 ohm has come to the extreme primary side. You will get the value 7 into 3 by 1 whole square, 7 into 9. Okay. So if you just add these two, 4 plus 7 into 9, 67, on voltage is 20, 67, what's this? I think I've taken value something wrong. I might have taken, no, process is obviously right. There is no problem with the process. That's fine. Oops, yeah, that's a problem what I'm facing. Okay, anyways, let's go with this. This is all right. For these numbers what we have taken, this is the right one. Okay, so nothing to worry. So this is 63, 63 plus 4, you will total get, this total will be how much? 67. I is equal to, this is current I, right? That number got changed. This is current I1. I1 is equal to 20 by 67. That's the answer. 20 by 67 is answer is 0.298. Take up to 3 decimals. All right. Okay. Let's go to the next question. First, this one to this side, and we add all these in series. Then this side. When you have more such kind of, maybe 3, maybe sometimes you may have 4. You may have one more transformer here. All things you will do like that only. You might see somewhere one more transformer over here, and the secondary over here. Okay, you will do like that only. Not everything just the same. Once you try to convert all this into by using this form, this will help you a lot. Transformation from primary to secondary, not only networks, I'm saying once again. Machines, transformers, induction machines, single phase, 3 phase, everywhere you will, transformation is very powerful. Okay, there is a foundation. For computer electrical engineer, magnetic circuit is the main thing, but we, unfortunately, we students, we don't normally encounter this magnetic circuits much. Whatever the reasons, okay, we should be careful with this. Next one. Find the values of I1, I2, V1, V4. This is the last question of the day. You need to find the value of I1 and I2, V1 and V4. Okay, very interesting one. Try finding this. Similar, just like before. Try. If you don't try, nothing will happen. Okay. I think question is not completely visible. It's just 400 ohm, nothing much easier, just 400 ohm. Okay, let me just take it. What we have here, this transform to the primary side. 400 goes to the primary side, you will have circuit something like this. While you are practicing, if you are lazy to practice, you will suffer when you are giving exam. Most of the students are lazy while they are practicing. No, let me not write it. You should write it. That's where the problem. Don't think these two are in parallel. These two are not in parallel. Okay, these two are not in parallel. 4 ohm, 240 ohm. Now this part this part will come to the primary side. This is a primary side. Of value how much? 400 into 1 by 5 square. 1 by 5 square. 25. 400 by 25. I'm not that good in mathematics. 16 is answer. This is 16. So this is 16 ohm. 240 and 16, they are in straight parallel now. Do the parallel operation. 240 into 16 by 240 plus 256. So right leg and right. You will get 15 is the value. This value is 15. Combination of these two is 15. That 15 and 4, they're in series. 15 plus 4 is 19. So this value is 19 ohm. So the resistance what will be here will be, after simplification, it is 19 ohm. Just give me a minute. Okay. Now, what is asked? Now 19 it transformed to the, this is 1 is to root 9. 1 is to root 9 is simply 3. 1 is to root 9 is simply 3. It's actually, sorry, it's 19, sorry guys. This is 19, not 9. 1 is to 19. 1 is to root 19, I mean. Okay. If it is 9, why to give 9? Simply they would have given 3, right? Okay, it's 19. It's 1 9 and this is 19. Now transform this to the primary side. If this is transformed to the primary side, then what will have? We'll have a resistance, and this will be here. This is 1 ohm. 19 into 1 by root 19 whole square. This is gone because square is here, square root gone. 19 got cancelled, you'll get 1 ohm. This is 10 volt. So I1 is how much? I1 is 10 by 2, that is 5 ampere. I1 is 5 ampere. I1 is 5 ampere. Now with this you tell me what is I2 value. With this you tell me what is the value of I2. It's easy. I just told you at the beginning, N1 relation, right? What is the relation? This relation. From this relation, I think you can say this. From this relation, you can say this, right? So here current is, in this current is how much? 5 ampere is a current. N1 by N2 is equal to I2 by I1. From this relation I can find this. N1 by, I'm talking about this, okay, not this. I'm talking about this. Let me write here somewhere over here. N1 by N2 is equal to I2 by I1. N1 by N2 ratio is given 1 by root 19. 1 by root 19. I1 value is known to you, that is 5. So I2 is equal to 5 by root 19. I2 is equal to, this current is 5 by root 19 ampere. This is I2. Okay. So I1, I2, remaining currents also you can find. Okay. For finding I3, you should be very careful. You should not take 5 by root 9. You should take this current, then you should apply this formula. Okay, you should find this current. For finding this current, here we got 16 ohm. Current in the 16 ohm, use current division rule. You take that, you try this, try to find this I3. That's an interesting one. That will be, I should use something like this. Here that was supposed to be, this was 4 ohm, and here 240 sorry, and we got here 16, I think, right? Yeah, 16. So now you should find out this current in this is not I3, this is this current. These two are same currents. By using current division rule, find this current, okay, and that current, and apply this N1 by N2 into I2 by I1, this current. Okay, you should take the current which is flowing through the winding, not coming input. That's the point. Anyways, now I1, I2 is over. Let's come to the other part, that is V1 and V4. V1 and V4. How do you find V1 and how do you find V4? Look at this. V1, just you can go for diamond rule. Start here, come back to here. Start here, come back to here. So simply I can write V1 is equal to minus 5 into 1, that is minus 5, plus 10, simply 5 volts. 5 volts is V1. Okay. Next V4. How do you find V4? Just think about it. You have two options. If you can find I3 into 400 is V4. Okay. So let's do that. That's one way. The second way is V1 is known now 5 volts. V1 is known 5 volts. 5 into root 5 into V1 by V2 is equal to N2 by N1 by N2. V1 by V2 is equal to N1 by N2. You know the formula. So from this 5 into root 19 is V2. V2 is, you'll get it as 21.79. Okay. So this is 21.79. Again, you'll have to apply voltage division here. Okay. Again the same change you will do here. Okay. After applying voltage division, let me just tell you. Or else, you know this current, right? You know this current, I can find this voltage directly. I can find this voltage again by diamond rule, because V2 is known, I2 is known. You can find this current, you can find this voltage and the voltage Vx, that Vx, and V4 from the Vx, I can find V4 by using this 1:5, 5 times more voltage. So V4 is equal to 5 times of Vx. Okay. Divided by 400 is this I3, or V4 is equal to this, that's it. Okay, that's it. So let me just do that. What I should do here, 21.79, 240 and 16, what was the resultant one we got? The resultant one of these two is 15 ohm. 15 ohm is a resultant one. Yeah, 15 ohm. So here we got 21.79 volt will be divided. So I want to find this voltage. That's a Vx. That's a V3. Sorry, that's a V3. That's a value of V3. V3 or Vx, both are parallel, right? Same. So 21.79 y 15 plus 9 into 15. You'll get V3 as 17.21. So V4 is equal to 5 times of V3. 5 times of V3. You'll get 86.03. 86.03. This is the V4. Directly we got this one. V4 is 86.03. Okay. There are a couple of ways you can find in by using current division also you can find it. Okay. If you want to do that, let's cross check. Here we got 5. This current is 5 by root 19. This current. I want this current. Current division rule. 5 by root 19 is how much? 1.147. 1.147 is dividing into these two. 1.147 divided by 240 plus this was 16. 1 got erased. It's supposed to be 16, right? And 16. I'm just applying current division rule to find this current. Okay. 240. I'm not explaining all those because you know current division rule, right? You will get this current as 1.075. This current is 1.075. Now I can find out this current. By simply voltage has increased means voltage has increased by 5 times, so current will decrease by 5 times. So by 5 you keep it, you will get this current as 0.215 ampere. 0.215 ampere. So voltage across this is 0.215 into 400. You should get 86. Yes, we got the same. Okay. So once you know the technique, you can solve in multiple ways. You need to be very well aware of the techniques. What you should be aware. That's a point I'm saying. It's not difficult. It's not even laborious. It's about the awareness. There are certain things which are difficult sometimes. There are some things which are laborious. They're not difficult but laborious. Means you need to do a lot of steps. But here they're very simple. There seems to be many things you're doing, but they are very simple. Okay, you need to be aware. That's the only thing. That's it for this lesson. My strong recommendation is you watch this multiple times and solve all these questions on your own. Pause the video and solve the questions and proceed to the next. Okay. Second time when you're watching this, you do this practice. That is the only way. Okay. Now that's the end of the session. I think you're already aware of Unacademy. That's why you're here. So Unacademy is having plus courses as well. Unacademy plus courses, those are the paid courses. Okay. If you like all these classes, what you're watching here, you can go to the plus subscription. There are different plans of subscriptions are there. Yeah, you can choose the best plan. What is what is more convenient for you. You can go with that. More structured live classes by all different educators are there. If you pay just once, you will get access to all the courses. Okay, according to the subscription. Now, if you're interested, you can use a code so that you will get a maximum discount also. You use this coupon code, you'll get the maximum discount which is available at the time. Okay, that's it. All the very best. Try to have a good practice. See you in the next lecture. Thank you all.